So hi everyone, my name is Alice Frosi. I'm a principal software engineer at Red Hat, and today we are going to talk about debugging technique using virtualization and containers. So for those of you that are not familiar with KubeVirt, Kubernetes allows some extension of its API and functionality using custom resource definition. And KubeVirt is actually one of those. So KubeVirt allows to enable, define, and deploy virtual machine in Kubernetes cluster. So when we think about debuggability, usually think about you have your laptop and you try to reproduce what is going on, wrongly going on locally in your laptop. This is, of course, not possible with KubeVirt because you need a Kubernetes cluster. And the virtualization stack is also deployed in a way that has some restrictions. So this has some challenges when you want to either use certain tools or try to understand what is going on. So first of all, Virt stack is deployed in an unprivileged container. So that means that libvirt and QEMUN are running in session mode, and they are run as with UID 107. So they are deployed in containers, so it means that they have been deployed in an isolated environment. So this basically means they have their own PID and mount namespace, for example. Additionally, especially for unprivileged container, you give the minimal set of capability to those containers. So, and this, for example, prevents certain tool to work. Additionally, KubeVirt images are distroless. For those of you that are not familiar with distroless images, basically those are container images without a package manager. So as regard of debugging, you cannot install on the fly some missing debugging tooling. So that makes hard to have your own preferred tooling in this kind of environment. So we are not running on our laptop. We need to run on a cluster because this is how KubeVirt works. So based on the cluster and the roles that you have in that cluster, you have different capability granted. So if you are a cluster admin with high privileges, so you can, for example, deploy privileged containers. But it's not the case and you are considered as a regular user, then probably your visibility, for example, is limited to your own Kubernetes namespace. So you cannot, for example, inspect core component like KubeVirt component. So all those restrictions plays a role when you need to understand what is going on. So don't be scared. This talk is exactly about this. So for the first command that I want to mention is kubectl. So kubectl is the Kubernetes client command that has various subcommands that help you in deploying container. And certain of those commands can also help you to debug. So for example, the classical and standard way to try to understand something, what is going on in your container is basically execing inside the container. So basically this creates, for example, a shell inside the same container namespaces as your original one. As far as it regards KubeVirt, KubeVirt has already included in the image a couple of tools that can actually help you to understand what is going on with the guest. So for example, we have virsh inside, so you can inspect the status of the guest, the XML, or we have also virt admin. We will see this also in the later slide, but this allows you to change the login level of the virtualization component. Something that is also included into the Virt launcher is QEMU-IMG, and of course, this is very useful when you need to inspect these images. So those you already get because are already installed inside the container image. So let's suppose that you have cluster admin, so you have this superpower in the cluster. So what can we do? So first of all, as I already mentioned, you have visibility in all the Kubernetes namespaces, and you can start privileged containers. We will see this in a second. So kubectl, again, has a subcommand called debug, and you can target with this command specific nodes. So you can deploy the container image that maybe contains additional tooling. And basically, these commands create a pod for you where you can attach and has already different things set it for you. So for example, it's running in the same PID namespace as the host. So for example, you are able to see all the processes that are on that node. Some other thing you can see is that the root file system of the host is mounted in this directory. So under host, you can, for example, inspect the release. So this is something that you can get easily with this command. However, the pod that is deployed using this command doesn't have the privilege flag set it for you. So certain operations are not allowed. So for example, trace is one of those. You cannot attach to a running process. So here on the left, you have an example, and you can see that I have set it in the security context, the privilege equal true, and we are running as root. So for example, doing this, we are able to, again, getting the QEMU process and maybe attaching to it with trace and start looking what QEMU does. Something that is also possible when you run as privilege is directly executing commands into the host. So as we saw, the file system of the host is mounted inside the container. So what you could do is basically chroot into in that directory, and basically you are directly on the host. So for example, in generic Kubernetes distribution, we have tooling like cryctl that allow you to inspect the containers, and you can use it exactly to see what's going on with your container. So in this case, we are using cryctl from directly on the host. For example, to inspect and find some libvirt directory in this case. So certain debugging tooling requires to have the target debugging tool binary. And again, from container, this might not be possible, or it might not be available. However, with KubeVirt, you can know exactly which KubeVirt release you are target to and which QEMU binary you are target to. So you can get this information from the KubeVirt custom resource definition. So these are some fields like observed deployment config and version. So basically from this environmental variable, you can exactly get the image that is deployed in your cluster. So once you know that, what you can do is referring that KubeVirt image. So Virt launcher is the image that has libvirt and QEMU inside. And basically from that version, you can copy it in your debugging container. So basically you can see that we are referencing this as a launcher. And here basically we are copying the QEMU binary inside the debugging image. So this is the way how you can reference, and get exactly the binary, the QEMU binary that you want to target for debug. So something a little bit easier. We, of course, want output. And the KubeVirt output level determines also the libvirt and QEMU level that will be printed on standard output. Of course, there are various changes how we can tune this. So KubeVirt works for using annotation. So annotation is a very generic mechanism how we can customize and pass additional information to pod. So KubeVirt has this annotation, libvirt log filters, where you can actually specify and tune the logging level of each component. So if you annotate your VM with this, basically you could increase or decrease the logging level of each component. So this is done at startup time. If you want to change it dynamically, how you can achieve this is basically, again, using kubectl exec. And as I mentioned, inside the image, we have virt admin. And basically, we can change the login level using that tool. Not only that, but we can also redirect to a file. So virt admin is able to specify a file, like here. And then kubectl has also something called copy that basically allow you to copy a file from a container locally. So you're able to inspect it locally. So something that KubeVirt has a feature called KubeVirt sidecars that basically allow you to modify on the fly the libvirt XML. So why do we do this? So KubeVirt has an API, and based on the VM definition, this basically implies a certain XML. But we don't support all the possible options that libvirt offers. So a way that we invented to allow users to customize the domain XML are exactly these sidecar hooks. So this is useful, for example, to try new feature or maybe even for debugging. So again, we need something called config maps. So for those that don't know what a config map is, it's basically a Kubernetes object that allow you to create file inside the container. So in this way, in the config map, basically we are creating a Python script that modifies the XML. If you want to use this config map with KubeVirt, again, you use an annotation. So on your VM definition, you can basically specify the sidecar hooks with the config map that contains the script that we want to run to modify the XML. So this is the most complex setup that we are going to see in this presentation. So please stay with me. But this is exactly an example of these sidecars. So let's suppose that I want to trace QEMU inside Virt Launcher. So as we said, we are using distroless container. So I don't have trace inside Virt Launcher. So how am I going to start QEMU with it? Another thing that I want to stress is that I cannot run QEMU and then attach to trace. This is not possible. I will get permission denied because that requires high privileges. So, but what we can do is start trace and QEMU as a child. So what I want to do is that libvirt, instead of starting directly QEMU, it will start trace plus QEMU. So this is the goal that we want to achieve here. Okay, so the first thing is how I get my debugging tool inside the container. So KubeVirt has something. So Kubernetes has something called PVC. You can think about a directory that you can populate. So what I wanted to do is provide a Virt launcher, a directory with my debugging tool. So how do I create the content of this directory? So what we can do is basically using a Docker file. So you can see here that I'm referring to CentOS 9 because it's exactly the same base image of a Virt launcher. And then I'm installing strays there in a directory. Additionally, I will also copy in that directory a wrapping script. We are going to talk about this in a second, but basically it's this file here. Okay, so I have installed strays with a dependency in this directory, and basically what I need to do is copy the content of this directory into the PVC. Okay, so this is the way how we bring additional binaries and additional file inside the Virt launcher pod. Okay, so we have talked about the sidecar. So now I want Liver not to start directly QEMU, but to start a wrapping script. So my wrapping script is actually this one. And you can see that it's basically strays with some output and QEMU. Okay, so now basically what I need to do is modify the Liver XML instead of calling directly QEMU here to calling my wrapping script. So and then when I click and launch the VM, basically Liver is now going to start QEMU directly, but it will start strays plus QEMU. So this is actually, I know, a bit complex way, but it's a way how we can customize and debug this immutable environment. Okay, I hope everything was clear. If not, please, in the Q&A, ask me more detail. So, sometimes we have images that have not completely or correctly been installed. So we want to inspect and see what is going on with this image. So I hope many of you are familiar with GuestFS tool. And KubeVirt has also a client called virtctl that has support for GuestFS tool. So if you call and use virtctl, GuestFS, and the PVC is basically a directory or a block device. Basically, this creates a container for you. And this container called GuestFS pod has already the GuestFS tool inside. It mounts the PVC in the right directory and also set up a couple of environmental variables. So you are actually already ready to debug your image. So here we have an example with Virt Rescue. So basically you can give to Virt Rescue the image, and maybe you need to fix the initRD using Dracu. So basically this is what the example is doing. So memory dumps. So if there is something going on your guest, you might want to dump the guest memory and inspect what is going on. So again, we have a support for this in KubeVirt. And again, we use the KubeVirt client. So virtctl as a command called memory dump. And then basically this command will create a dump for you. So how this works? So you have Virt launcher with Liver inside and QEMU and your guest. So Kubernetes pods are very static, so it's not possible to add dynamically new volumes. But KubeVirt has this functionality. It's something that we build on top. It's called a volume hot plug. And this is one of the features that we are using here. So we are able to dynamically attach a new volume. We'll get the dump there. And when that is finished, so you can monitor also the status of the dump from the VM status, we can detach it. So something that also we would like to get is, because right now this is sitting in the cluster, is to download it and have it locally. So this is, again, another feature that KubeVirt has that's called export. So basically, using hot plug and export, we are able to dump the memory of a KubeVirt VM in the cluster and get the output locally. So something, again, useful is, of course, getting the console of your guest. This can be done in different ways. So virtctl has support for the Syria console or for VNC. So this is if you need something interactively, or something else pretty nice, in my opinion. There is another container inside the Virt Launcher pod that's called the guest console log. So basically where we redirect the guest output. So if you are familiar with Kubernetes, then you basically just get the container log. So you get the logs as a standard container. So I would like just to mention a couple of nice Kubernetes debugging technique. So kubectl logs and kubectl describe allow you to get the log of the pod and also to get more information about the pod. So if your pod is not going to work, those are one of the commands that you want to use immediately. Something nice is kubectl port forward. So if your container doesn't behave properly, then maybe you get the port is not reachable, something like this. You can use this in order to forward the port locally and inspect what is going on. Kubectl debug we have already seen for the node, but this command also allows you to start additional container in a running pod. So this might be something useful, again, for debugging. And something nice is checking the events that are happening in your Kubernetes namespace. So basically, those are a list of events that happens for different resources. So this kind of give some kind of history. That's good to know sometimes for troubleshooting. So for KubeVirt, a couple of other tricks very quickly. So KubeVirt supports different annotation, and those two are pretty useful when you want to debug something that maybe your Virt launcher crash. So the first one basically keeps Virt launcher pod running. So the standard behavior is usually when QEMU exit, also Virt launcher exit. But sometimes you want to inspect the environment. Maybe there is a permission denied or something not set in properly. So this is quite nice. And the second does the same, but for migration. So for migration, usually we have two pods, one for the source and one for the destination. Basically, the two libvirt. And yeah, if there is something not working properly on the destination, then you can use the second annotation. So virtctl also has port forward, so the same, but for if there is a port not properly working on your VM. Virtctl ADM log verbosity allow you to change the verbosity of KubeVirt component. This is something that maybe it's helpful for you to debug KubeVirt itself. And if your guest has the guest agent, the QEMU guest agent installed inside, you can get the information using, again, virtctl guest.os info VM. So I hope that this was useful for you. It was mostly an overview of what is possible and what are the problems. And yeah, just keep in mind, try to understand what are your role in the Kubernetes cluster, and kubectl and virtctl are your debugging companion. Thank you for your attention. Do we have any question?
So you showed how you can have this annotation that gives you the sidecar hook script, which is very nice and integrated. But then for the wrapper script, for example, you had to create your own container image and add the script and everything else. Is there a chance that we can have something like that for a wrapper script integrated in a nice way, the same way that the sidecar hook is, so that people don't have to fuss as much? Because that looked like the worst case scenario for setting up the debugging environment.
So for the script, yeah, the problem is it really depends on what you want to achieve. So the wrapping script is like some additional debugging tool. For example, for those example, I needed also trace binary. So you need something opaque. It's not something that you can support easily.
Arbitrary
Yes.
modifications. But could we make the most common use case, like install an additional package in a known base image, basically, and add the wrapper script? Could we make that smoother?
I think so. So there is something called OCI artifacts that got alpha in Kubernetes 1.3.2 or 1. Sorry if I'm mistaken the version, but pretty recently, that allow you to basically reference a container image as a volume. So basically what you could do from that slide that I show, you create your Docker file with all the things, and then you can reference in the content from a volume. I think that will make that setup much easier.
Hi. I had the impression, based on the examples you gave, that most of the debugging happens like post-mortem, like when you run strace, you direct to a log file. Does it change too much? Is it possible to have some kind of live debugging like GDB or something like that? What are the challenges for that?
So GDB, actually, I tried to run GDB with the -s option, and I failed because liver was not. QEMU was just ignoring that option. But what you can do, instead of starting QEMU with strace, you could start with GDB. And then you can have a local client and connect to it. So basically,
using GDB server, something.
Yes.
Like
so I have some reference, and you can see that, and I exactly explaining also the GDB, how you could do GDB interactive session.
Okay.
It was just more complicated for the slide, but it's already explained into the in the KubeVirt user guide. So we have also the GDB example.
Thank you.
Hello. I noticed the latest KubeVirt 1.40 alpha version based on the libvirt 10.0 and QEMU 8.2. So my question is, this version is behind of the latest libvirt and QEMU version. So my question is, how to debug the KubeVirt failures based on the latest QEMU and libvirt version.
Do you have any specific way how you would like to debug? Because it's about the output, or
Yeah, just use the latest libvirt and QEMU version. Maybe is it possible to build this word launcher or image and so on?
you need to build Virt launcher with the latest KubeVirt and QEMU, but this is about building. It's another complexity. But theoretically, what this work should work with all the versions. So I'm not sure, or are you talking about upgrading libvirt and QEMU for debugging? Is it that the question?
Okay, thank you.
Okay.
So we are out of the time.
Okay, thank you, everyone.